Okay, let's move ahead. So far we have discussed all the points. I showed my implementation to you also how to do that. You always make left is equal to mid plus 1 or right is equal to mid minus 1 to avoid the boundaries. Okay. So let's do these questions. So I'll give you 5 minutes to think over these questions. Let's start with the first one. Right? You need to find if A or minus A. You are given a variable A and you need to figure out whether it exists in an array that is sorted by the absolute value using binary search. I encourage you to think for some time and tell me. I think the first question does not require a predicate array. Sorry, a predicate function. It is straightforward binary search. Hello. Okay, so uh, given this implementation, how would you do that? Can you tell me the exact funda, the exact logic? What would you write in if? Hello. Absolute value of mid, no? So if absolute value of mid is equal to A, okay, then answer is equal to A, right? And we simply break. Or maybe, yeah, that is one and the same thing, man. This is one and the same thing. So basically, if you find it is equal to mid, then we simply write answer is equal to true or something like that and simply break. Right? Now, if it turns out to be less than mid, less than A, then what to do? And R is equal to mid minus 1. So is this clear to everybody? Basic binary search. Right? Okay. Okay, let's move with the second question. Okay, I think this was implemented only. How would you do this? This is also pretty straightforward. You need to find the first index of an element that appears in a sorted array. And if it doesn't appear, report minus 1. Yes. First one or second one? Let's say you are given an array and you are given an element. Okay. You need to check or you need to tell that whether uh, you need to tell the first index of that element in the array. Let's say you have an array 1 2 3 4 5 5 sorted array. Okay. And you need to tell the first index of 5. Hmm. And if it doesn't appear, then you need to report -1. Okay, anybody having any approach in mind how to do? Okay, right. Getting the point. Okay, so can you just quickly tell me the code? Pseudo code rather, not code exactly. Okay, if equal to a, then answer is equal to mid, and you can do, yes, exactly. Okay, okay, if less than a, then what to do? L is equal to mid plus 1, right? And if, so you will simply write else if over here, and here else. Okay, and initially you will initialize answer with -1. Okay, so if you don't find anything, simply report -1. Getting the point or not? Okay, so is this process clear to everybody? Okay, let's move on with the third question. Okay, you need to find the first position of an element. Okay, okay. So if you get, first of all, if you find mid, if you find that the value at the mid position is equal to a, right? So we first store it, right? We can say that this can be the first position, and we will simply check the area. Either this, if we find that element to be equal to a, then either that could be the first position only, or the first position would lie to the left of that part. Yes or no? But if the value at mid is less than a, then we obviously know that a will lie to the left only if it exists. So we will simply do r is equal to mid minus 1. Right or wrong? Hello? Hmm. Ha. We would return answer. We are storing that, no? You check the code. Answer is the position which we want to return. First, we are checking if the value at mid is equal to a. Okay, so if it is equal to a, we know that either that would be the first position or the first position of that element would lie to the left of it. So first we store it, assuming that that is the first position, and if it is not the first position, we will automatically reach to it by doing r is equal to mid minus 1. Got it or not? Okay. Do the third question, please. Okay, anybody having any approach in mind for the third question? Hello, am I audible? Okay, so we need to find the integer square root. So when I say integer square root, does that mean that we need to find the largest integer, largest I, such that I into I is less than or equal to the required given number? Yes or no? Okay, so can we do that using binary search or not? Okay. Okay. So again, we'll start with the same procedure which we did just now. We'll initialize answer. Okay, let me remove all this first. Okay. So first I'll check if mid into mid is less than or equal to number. If such things happen, then we know that answer would be either answer it would be the answer, or it would lie, or the answer would lie to the right. So we would make L is equal to mid plus 1. Else I is equal to mid minus 1. Hello? Is this clear to everybody? Yeah, 0 and end. Yeah, let me write this down. L is equal to 0, R is equal to n. Yeah. Well, it doesn't matter whatever R you take, but L should be start from 0. So this is the best case. L is equal to 0 and R is equal to n. The answer would lie between these two values only, right? So is this process clear to everybody or not? Anybody having any questions, any queries? Hello? Okay. Okay, this is the last question. This is also pretty straightforward. Exactly similar to what we did just now. So here we'll simply change mid into mid plus 1. Mid into mid plus 1 by 2. But here equal to won't come. We want strictly less than. Right? So it's given in the... Okay. So equal to won't come. Rest everything would remain the same. Okay. So are these questions clear to everybody? Anybody having any doubt, anything to tell? Or shall we move ahead? Okay. So this is the question we have already discussed, right? The second question, we discussed all of them. Okay, and this is the binary search which I was talking about. No need to remember this implementation. I already showed my implementation, and trust me, you won't get stuck into infinite loop anytime if you follow that implementation, because you are always changing L to mid plus 1 or mid minus 1, so it's never an issue. Okay, so when we are doing binary search on answer, take the set of elements as a range where the answer can exist. So this is very straightforward, right? I just now told you. If we are finding an answer which satisfied a particular condition. So let's say we have a particular condition, like the condition is this. We need to find this answer n, right? And what is the condition? Sorry. We need to find this largest n and such that n into n plus 1 by 2 is less than this, right? So this n is our answer, and we must know the search space. The search space would be from 0 to that given number. Yes or no? Hello? So that is what it is telling. We must be very clear with the search space in which we are searching, and then we just need to apply the binary search using the concept of predicate function. So this is very straightforward, right? So square root of a number we just now did, and guys, please try these two questions. If you have any doubt, just post on the Discord server. Okay, these are straight questions related to binary search only, the based on predicate function which we did just now. Okay, so let's move ahead. So now we'll be moving to two pointers. So binary search is clear to everybody or not? Okay, okay, okay. So predicate function. Hmm. So wasn't this a predicate function? See, I'll tell you how it was used. You see the last question. Largest n such that n into n plus 1 by 2 is less than the target. Okay. So here, this thing is a predicate function, right? You can implement a boolean function using this. No, so let's say you write something like this: bool function, and you write return mid into, okay, and okay. You see, this function is satisfied something like this. For few values, this would be true, 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 right? Up till the required value which we want, and then it would become false, 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 false. Right or wrong? So isn't this a predicate function? Exactly, and you need to find the last true element. And same is the case with that square root function which we did just now. So this is itself a predicate function, and you will get a clearer idea when you solve these two questions. Actually, these two. Okay. Yeah, the code forces ones. Okay, so let's move with two pointers. So two pointers, as the name suggests, it consists of two pointers or two variables which move in one direction only, either left to right or right to left, as the case may be, and they move according to a certain condition, right? So as it is written over here, two pointers algorithm is used for finding solutions using two pointers, so two variables which are used to locate the elements, and they move in one direction only, either left to right or right to left. Okay, and the complexity would be linear complexity O of n, right? Because they move together simultaneously, and hence the complexity will be O of n. This would be clear when we do one question, right? Okay, in some cases, two pointers can replace binary search. I'll tell you one case also where it does. So let's move ahead. Give you one question before that so that it will be much clear. Okay, so please note the question. So you are given an array A of length n. Okay, array A of length n, and you need to find two elements which sum up to x. Okay, so if this is the question, okay, so you need to find two elements which sum up. If they don't exist, then we need to report -1. So I'll implement two pointers using this. Okay, so first what I'll do, I'll take two variables I and j is equal to n minus 1. I will point to the first element and j will point to the last element. Okay, okay, so first I'll take the sum of these two elements, a of I plus a of j. Okay, if a of I plus a of j, it becomes greater than x, right? And assuming this array is sorted, okay, we need to find this in a sorted array. So if the sum of these two elements becomes equal to x, we obviously know that we need to reduce the sum. Okay, So in order to reduce the sum, we will reduce j. Yeah, so we'll reduce j, no? Else, if they become equal, sorry, we simply break and report the answer. Else, I plus plus, right? So when I say I plus plus, we are basically trying to increase the sum. And when I say j minus minus, we are trying to decrease the sum. Is this process clear to everybody? You see, both the pointers are moving simultaneously only. So the maximum. What I mean by same direction means they don't change the direction. If it is moving from left to right, it will move from left to right. If it is moving from right to left, it will move from right to left. Same direction doesn't necessarily mean both are in the same direction. It means that they don't change the direction. Exactly. But here they always move in the same direction. Right? So this algorithm is better than binary search because if you see that predicate function, so in the examples that we did, the predicate function was consuming O of one complexity, right? If you see these questions, binary search and answer like these ones, right? Here the predicate function was consuming O of one time. When you solve problem on code forces, the predicate function will take O of n time. You will see such questions when you solve the problems which I gave and other problems on code forces. They will take O of n time. So when you apply binary search on answer, the total complexity would become O of n log n. However, in some cases, binary search can be replaced by two pointers, and thus we can reduce the time complexity from O of n log n to O of n. And you will get such examples soon. Okay, so as you solve questions, you will be able to know where to use two pointers and where to use binary search. Okay, so let's start with these questions. Reversing an error. So you want to know what exactly is binary search, or you want to know what is two pointers? See, two pointers is basically, as the name suggests, we have two pointers, or in short, two variables, which point to a location or which point to an element in the array or something like that, right? Which point to a memory location in short. And we move those two variables according to a certain condition. That is two pointers. The only fact that you need to know is these two pointers never change their direction. They are unidirectional. Okay. Now, how they have to move and where is their initial position, that solely depends on the question. So, in the question that we solved, one pointer was moving from left to right and another was moving from right to left. There may be cases where both the pointers move from left to right only, or both move from right to left only. That depends basically. Is this clear to you? So, as you solve questions, you'll get to know how we apply two pointers. You solve these four questions. Start with the first one. So, you are given an array and you need to reverse it. Don't create an additional array. Just simply make changes in the array given only. Hello. Yeah, exactly. So, what basically we would do is something like this. So, we start from 0 and j is equal to this. We'll swap a of I, a of j, and then do I plus plus, j minus minus. Done. Getting the point or not? And we will do this under a certain condition. That is while I less than equal to j. Suppose if I goes beyond j, then we would again get the same array only. We would be reversing them twice. Getting the point or not? right? So we need to take care of this condition, right? So these pointers move under a certain condition, and we just need to apply operation, that is two pointers, nothing else. Okay, do the second question. This is also very straightforward, right? We just need to check if I and j are equal or not. Hello? Exactly, exactly. And rest everything would be the same. Okay, let's move on to the third question. Okay, is everybody clear with second question or not? Okay, so let's move with the third question. So basically, you are given two sorted arrays A and B, right? And you need to merge them into a single array that is sorted. So if size of A is n and size of B is m, then the size of new array would be n plus m, and that array has to be sorted. You need to find that array. Exactly. Yes, exactly. Yes, 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 exactly. Okay. So this is the correct approach. So I is equal to 0. This is the pointer for the first array. J is equal to 0. This is for the second array. Right? And this k is equal to 0 will point to the new array. Right? So at which location have we reached in the new array? That will be the k. Okay. So now very simple condition, while I less than n and j less than m. Okay. So if this element is smaller, then we'll put it in the array C of k is equal to A of I plus plus k plus plus. Right or wrong? Right? We kept it in the array and we moved to the next place. Else C of k is equal to B of j. I j plus plus. Okay, so let's say I'll give you an example only. So let's say you have these array. Okay, so you have these two arrays A and B. Okay, and you need to find a new array that is a union of these two, or this is the combination of these two arrays merged together, and the new array must be sorted. Okay, hello. Okay, so first our pointer points to this location and this location. Okay, okay, now we see. Yeah, obviously anything can be, the only condition is the array must be sorted, nothing else. You, so you can have something like this also. Okay, and it doesn't matter actually. Okay, so we start with the first element of both of them, I and j. You see which is smaller? 2 is smaller. Okay, so we'll keep 2 in our new array and we will move our pointer to this. So now I is 1 and j is 0. Okay, okay, so okay, now we again compare both I and j elements, and again we put the smaller one into our array and move the pointer and keep the larger pointer as it is. This is what we are doing continuously. Yes or no? Okay, now there might be a case where one pointer reaches the end of the array, but the other pointer hasn't reached. So, would this condition come or not? It would come, right? So, here 2, 3, 4, 5 would get inserted, and I would come at the end, and we would be out of this loop. But still, we haven't merged the complete array. Is everybody getting what I'm telling? Okay, so once one of the iterators has reached the end, we can simply put the elements of the other one directly into the array without doing anything. So then you write something like this: C of k is equal to A of I plus plus k plus plus. If I is left out, put I. If j is left out, put j. Okay. If I is left out, put I. If j is left out, either of them would have reached. So only one of these two loops would run. Right or wrong? Okay, so finally we have merged the array. Is this process clear to everybody? हाँ हाँ. अरे पहले ही बोला है ना, दोनों एरे सॉर्टेड है. आप ये काम ही तभी कर सकते हो जब दोनों सॉर्टेड है. समझ रहे हो? अगर दोनों सॉर्टेड नहीं है फिर तो आप ऐसे आगे ऐसे कैसे बोलोगे कि आगे वाला एलिमेंट उससे छोटा बड़ा ही होगा? नहीं बोल सकते ना, फिर तो टू पॉइंटर्स का मतलब ही नहीं है. Okay, so we are done with the question, and you try this out. Okay, this CSS problem set. Okay. Actually, I have a hard time recalling that, man. I am still not able to recall that. I have seen many examples actually where the time complexity get reduced from n. Okay, you till then solve this question, the last one. I think last one we have done only. I just now showed you. Yes or no? No, no. This is not, is not done. Sorry, sir. Okay, guys, try this question. Last one. Find ij such that a of I plus b of j is equal to x. By that time, I will recall the question. Oh, hello, hello. One of you was asking, no, that what is the question in which two pointers can be optimized, at two pointers can be used instead of binary search. I'll tell you that question. So you have an array A, and you need to find two indices where something like this, or is closest to x, and it is smaller than x. Okay, ai plus aj should be smaller and it should be closest. So you need to find these two elements. So if you want to do this question, this can be done using binary search also, and this can be done using two pointers also. So can anybody tell me how to do that? First using binary search. Hello. No, I and j you need to find. No, how would you take that? And assume the array to be sorted. Okay, assume that the array is sorted. Hmm. Okay, mid. Okay, fine. Huh. Okay. But see, 1 second. You need to find two unknowns. When we apply binary search for answer, if you observe closely, then we can find only one unknown, right? But you need to find two unknowns. So that is the catch over here. See, I'll give you one hint. Okay. First of all, you guys tell me, if I give you a number, right? If I give you a number, how would you find the how if I give you a number and an array of numbers, how would you find the number in the array that is closest to the number that I gave and it is smaller than that using binary search? Let's say I give you a number a num. Okay, sorry, I give you a number num and I give you an array a. Okay, and I want you to find the closest number a of I such that a of I is less than equal to number. Can you do this using binary search or not? You tell me. Exactly. Okay, exactly. So now what you do is, for every I you apply this process. Simple. First you take I is equal to 0. Okay. You take I is equal to 0 and you assume num to be equal to x minus a of I, a of 0 in this case. Now find the other index which is closest to this. Then you take I is equal to 1. Okay. And do the same thing. Yeah, exactly. So I'll tell you the pseudocode. See, just a second. Okay. So for I from 0 to n minus 1. Okay. And here you assume a number num to be equal to x minus a of I, right? And here L would be equal to I plus 1, R is equal to n minus 1, and apply binary search. This you already know, right? How to do this. Hello. See, if the required index is to the left of I, then we would have automatically found out, no? Let's say the answer is 0 and 3. So during 0 only you will find out any index greater than 0, right? For I is equal to 0, any index greater than 0. For I is equal to 1, we are already done with 0 1 case, right? We already, Exactly. So for every index, we will only see the space that is to the right of that index. No need to worry about the left because that is already being taken into account. Okay. And this binary search process you already know, right? So, yeah, that is what you told just now. So I'll tell the process what he told. So what basically he's told is I'll find the mid. Mid is equal to L plus R by 2. And if A of mid it turns out to be less than equal to X, then our answer, we'll declare one more variable answer. Our answer would be equal to mid and L would be equal to mid plus 1. Else R is equal to mid minus 1. Okay. So what is the time complexity of this solution? N log n. Okay, n log n. Now I encourage you to do this using two pointers. The same question can be done using two pointers. Similar to the first question that we did, which I told you when I was teaching two pointers, when I was giving you introduction about two pointers. I'll erase this part. Now try this using two pointers. This question. Okay, so I would give you one hint. If I want you to find something like this, array A, and I need to find, you need to find A of I plus A of J is equal to X. Forget this thing over here. You forget this thing. If I wanted to find something like this, two indices I and j such that A of I plus A of j is equal to X, then how would you do it? Anybody? The original question that I asked is to find A of I plus A of j that is closest to a number X and it is strictly less than or equal to. Okay, yes, exactly. So think in that same direction. Think in that same direction. So, did you get the solution of binary search which I told just now? So, the question for that, the solution the that binary search solution is actually the answer to the question. So that is all you need to think, no? Okay. So I was giving you basically an analogy to this question. I discussed this question, right? You need to find two indices I and j such that the elements at I and j index the sum of 2x. I discussed it or not? Do you recall? Okay. So what I basically was telling was that you need to think in this direction only, right? The original question is you need to find indices I and j such that a of I plus a of j is less than equal to x and they are closest to x. This is the actual question that we want. And you can think of this question using the logic which we used in this question. That is what I was telling. Hello? So is anybody able to come up with something? Huh. No, but we need to find less than equal to, no? We don't need to, less than is also required, man. There may be a case that equal to is not there only, but still you need to report the closest one. So you are in the right direction. See, I'll tell you. As you said, we'll take I is equal to 0, j is equal to n minus 1, and we'll take two variables, answer L and answer R, to store the indices, right? This would be the answers for the left and right indexes, okay? We'll initialize them to minus 1, okay? And we'll take one variable, difference, okay? Difference means it will denote how far is ai plus aj from x. So it will basically store the difference of x minus a of I minus a of j. This is what it will store. Getting the point? So I'll first initialize it to let's say a very big value. Let's say infinity, or maybe L long. Let's say 10 to the power 18. Okay, let's for time being 10 to the power 18, or anything you want to, a very large value. Right now we'll start applying two pointers. So the condition would be while I less than equal to j. Hmm? Sorry, I less than j, not equal to. And as we discussed, so if a of I plus a of j, if it is less than or equal to x, okay, then we will find the difference, a temporary variable. So we will find temp is equal to x minus a of I minus a of j. Okay. Now if temp, that is less than difference, okay, we need to find the minimum. We need to make the difference as minimum as possible, right? That is what it means by closest to x, right or wrong? So if the difference that we are getting currently, if it is less than the value that we have, then that would, yes. So that would be our answer. So answer L is I, and answer R is equal to J. Okay, and the difference now is equal to this one, right? And else simply do J minus minus. Getting the point or not? Okay, so here you would get two things. the one that is closest also and less than also, because we are only applying this funda for when a of I plus a of this less than equal to. Okay, so is this logic clear to everybody or not? It's basically this: greater than x. A of I plus a of j is greater than x, j minus minus. And I forgot to do one thing. I forgot to do I plus plus over here. Okay, is this thing okay? So you saw the difference. Firstly, we were doing this job in n log n time. Now we are doing the same job in O of n time. So you saw how two pointers replace binary search. Okay. Exactly. So there are cases when we can only use binary search. There are cases when we can only use two pointers. There are cases where you can use both, and time and two pointers can be used to optimize binary search. That is all I wanted to say. So please try the last question and then we'll wind up. Okay, so I think the last question is very straightforward. So can anybody tell me how would we do that? Here instead of one array we have two arrays. That's the only difference. Hello. Hello. Am I audible to you? Okay, so is anybody able to come up with some approach for the last question? Okay, so this one is very straightforward. I'll quickly discuss that. So I'll take two pointers, one I is equal to 0 and j is equal to m minus 1. So here n is equal to size of array A and m is equal to array B size. Okay, and both are sorted. So now the condition here would be I less than n and j greater than equal to 0. Okay, so we'll apply the same logic which we did. If a of I plus b of j, if that comes out to be equal to x, simply print both of them, maybe print ij and simply break. If they turn out to be less than x, okay, then we obviously need to increase the sum. So we will do I plus plus, else we will do j minus minus. Done. Is this thing clear? Okay. So what I did is I took two pointers. One points to the start of the first array, and the sorry, I'll remove this part first. One points to the start of first array, and the other one points to the start of to the end of the last array. Right. So one, see, because we need to move two pointers. First, we'll check the sum. See, हाँ, अगर ऐसे करना है तो फिर अगर मान लो सम ज्यादा आ रहे, if the sum is coming out to be greater than x, then what would you do? You would increase I, but you can increase j as well, right? What to do? Yes, exactly. That is what we are doing, right? If the sum comes out to be greater, then move the right pointer. If it is less, then move the left pointer. Right? So that is something you really need to think how to place the pointers, right? That comes with practice actually. Okay. So if the sum is equal, so we are done. We'll simply print and break from the system. If it is less than, then we'll move I to increase the sum. If it is less than, or if it is greater than x, then we will decrease the j. Getting the point or not? Anybody having any doubt on whatever we taught, whatever we studied till now? What infinite loop? I did not get it. Yeah. See. I'll tell you one thing. You check this implementation. Okay. Here they are doing left plus right plus 1 by 2. For time being, you assume that we generally do left plus right by 2. Okay. Now, let's say after some iterations, left become right minus 1. So if you find, okay, left might became right minus 1. Now you find the, sorry, you find the mid. No, for left plus right by 2. Huh. So, you know that divide by 2 is basically flooring it down. So it would be L only, right? Let's say 5 plus 6 by 2 is 5 only, no? These are in integers, right? So it won't give you 5. Ah, it will give L, no, not R. It will give R minus 1. No, you do it clearly. See, take L is equal to 5, R is equal to 6. 5 plus 6 is 11, 11 by 2 is 5. So it is L. Okay. Then you check this condition again, left is equal to mid only. So left is equal to, so left is not changing only if you see clearly. There might be some case, no? So left is equal to left, so you are not terminating out of the loop. There should come some case, no, when left and right become equal. It would never happen only. There must be some case when we come out of the loop. No, there must be some case where left becomes equal to right. Only then we would come out of the loop, right? But this would never happen. But if you check my implementation, which I told you, we are always incrementing or decrementing. We are never keeping it equal to mid. So there is never a chance of such thing happening. Getting the point? Yeah. So how would we come out? Okay. So that is why I suggest you to do that implementation which I showed you. That storing a temporary variable and always do left is equal to mid plus one or right is equal to mid minus one only. So this situation won't arise only. Okay. Apart from that, any other doubt? Hello. Okay. So thank you everybody. We'll see you in the next class, and these are the additional resources you can refer. Okay, for binary search and do pointers, and practice the questions, and you'll get better at binary search and do pointers. And see you in the next class. Thank you. Yes, yes. Okay. Guys, bye. Thank you.